Here are some examples of L'Hopital's rule. For example, number 1, the limit as x goes to infinity of log x over x. And notice that if we just try to take the limit individually, the limit as x goes to infinity of log x is infinity, and the limit as x goes to infinity of just x is just infinity also. So what we have here is an infinity over infinity ratio, which is indeterminate, which means we are allowed to use L'Hopital's rule. L'Hopital's rule tells us that this limit is going to be equal to the limit of the derivatives of the function. So the derivative of log x is just 1 over x. The derivative of x is just 1. And so this is the limit as x goes to infinity of 1 over x, which is 0. And that, in fact, is the limit. This function, log x over x, has a horizontal asymptote of y equals 0 as x goes to infinity. Now the next one, number 2, this is curious because here we have a product. We take the limit, it's supposed to be 0, take the limit as x goes to 0 of e to the x minus 1, then what that equals is 1 minus 1, which is 0. Take the limit as x goes to 0 of cosecant x. Well, that has a vertical asymptote, so that goes to infinity. And so what we have here is an infinity times 0 situation. And this is also something that is an indeterminate form. And the way we handle this is we need to rewrite this 0 times infinity either as a 0 over 0 or as an infinity over infinity. We need to write it as one of these two ratios before we are allowed to apply L'Hopital's rule. Well, here it's particularly convenient because we can just take the reciprocal of cosecant. The reciprocal of cosecant is sine. So we could write this as the limit as x goes to 0 of e to the x minus 1 over sine x. Well, now, numerator goes to 0 and denominator goes to 0. So we have a 0 over 0 limit. This is a bona fide indeterminate ratio, and we are now allowed to use L'Hopital's rule. So L'Hopital's rule tells us that if we take the derivative of the numerator and the denominator, so derivative of the numerator is just e to the x, derivative of the denominator is cosine x. Well, now when we take a limit of this, what we get is 1 over 1, which is 1. And so it means that this function, as we approach 0, has a limit of 1. So we expect that function to have a hole at 0, 1. Those are two examples of L'Hopital's rule.